Hi, I'm Alex Lamb, author of the Roboteer science fiction novels, and welcome back to Secrets of the Universe, the exciting video sequence in which I attempt to answer all of the major questions that bedevil mankind in one series on the basis of no specific technical professional expertise whatsoever. But hey, here we go. Last time I talked about the first of the three exciting learning tools that I use to glom scientific fields and whelp them into my mind. That first one was spider reading. I like spider reading because it's a way to internalize a lot of information on a given topic without burning your brain out at the same time. Rather than imagining that you have to go and do some deep and complex course and read a bunch of textbooks and what have you, you essentially read a bunch of pop science books and iterate backwards and forwards over the subject casually and lightly, many times from different perspectives, until you have enough information that you can use to then go and dive deeper into something. Quite frankly, YouTube is another tool via which you can do something very, very similar, and that's why we're here, ladies and gents. My second tool today that I want to talk to you about is agent-based modeling. Now, that might sound a little bit sort of scary and computery, because it kind of sort of is, but ironically, it's a far simpler topic than you might imagine given the name. Normally when people think about computer programs, they think about sort of like web servers and databases and complicated bits of business logic. Oh, Mr. Smith as well. Was he, was the client somebody who was born after 1965 but doesn't wear blue shoes and isn't interested in Elvis? Then they might be amenable for such and such a program. All of that sort of stuff. None of that. What agent-based modeling is essentially, it's where you write a zero-player game. Use very, very simple tools. If you've done a high school computing project and you've used language like Scratch, or you've mucked about and written a page of JavaScript, chances are you already have the tools and the means to do agent-based modeling. Strange, exciting. So why is that? How does that work? Well, the answer is, if you want to understand a scientific topic, you want to really, truly grasp it, there's no better way to do that than to test what you think that you have learned. And there are different ways in which you can test it, but the magic supercomputer in all of our pockets, ladies and gents, is an extraordinary tool for doing this we barely make use of. So one thing that I do is, if I think I've understood a subject, if I've read something about like biology, let's say, or physics or some such thing, I then try to write a little computer program that will replicate the kind of thing that I think that I've learned. So, and what do you do with an agent-based model? Well, an agent-based model, what you do is you create a bunch of little characters, mini critters, if you like, little guys. And then you create a bunch of rules for them to live by. And so once you've got your agents and you've got your rules, then you press the go button and you watch them interact with each other. There's a bunch of non-player characters, pew, 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 all sort of shooting each other with love or loathing or money or knowledge, whatever it is that you are trying to model. Anyway, you have your critters interact in such a way, and the upshot of this is you get to see the consequences of how these elements behave together. And you can do this for a huge number of different subjects. As it turns out, you can do this in biology, you can do it in economics, you can study sort of human social psychology, you can even do it for fundamental physics. And that's because the agents don't necessarily need to model people. They don't need to model sort of like characters with hats. They can represent genes. They can represent sand grains. They can represent voxels of Planck length space-time, or many other different things. The idea is that your little particles your agents can be many different things. Now, the way this particular method of using computer programs comes out of complex systems research, a wonderful domain that we will talk about in later videos. Now, you might think, well, Alex, isn't the kind of model that you're describing there one that's only applicable to complex systems? To which my response is, complex systems is everything. Complex systems are a magnificent domain of learning, touches pretty much every single other sort of scientific discipline via which we try to understand the world. So here's why I'm really passionate about this particular subject. It's until you test your ideas, you're guessing. All of us are guessing. There's this thing that happens in the world where people take on like political opinions. I think that if we reduce taxes, or sort of like if people could only just listen to me and do a thing, then the world would be a very different place and everything would solve itself. What's wonderful about building models is that it gives you the opportunity to discover whether or not the ideas that you have about how society works or nature works or love works or whatever it is that you have in mind actually pan out the way that you imagine they do. And that, ladies and gentlemen, gives you the foundation for learning and coming up with new ideas and testing, extending the model of what you know and growing and becoming a fully fledged, all-discipline scientist in your own right. And that's what it's about, ladies and gentlemen. Thank you for watching. Next time, learning tool number 3.